Hi folks, so in this video what we're going to do is a question here from the 2022 exam paper. It's the higher level DCG paper and the question was B1 on that paper. Based on the topic here, I know it says oblique plane, but I would call this intersecting planes, okay? So it says here B1, the image on the right shows the Hooker sculpture in Ayr Square in Galway. The geometry of the design comprises of a series of planar surfaces. The figure B1 shows the plan and elevation of three intersecting planar surfaces. Okay, so we've got ABD, ABC, and EFG as well. It says the horizontal and vertical coordinates for points A, B, C, D, E, and F are given. Partial coordinates for the point G are also given. The edges BD and FG are parallel. So you can see here BD and FG are parallel, and likewise in plan BD and FG are also parallel. So what we have to do is part one, draw the given elevation and plan of the intersecting planes ABC, ABD, and EFG. And you can see here we're only given certain coordinates for a point G, so we'll have to find those. Now, we're going to plot these coordinates and we're going to start with point A. Now, what I always usually do here is, based on the coordinates, basically, how would I describe it? This is the measurement in, this is the measurement up, and this is the measurement down. Okay, so basically what I'm going to do to find point A, I would go in 160, I go up 40 and down 70. So that's in, up, and down. And that's how we locate our points. Now the way I do it to save me a bit of time is I look at the first measurement here for all the letters, and I'm going to number them of how I'm going to do them. So A, 160 is the lowest, I'm going to number that number 1. What's the next one closest to 160? Will be 180, number 2. And then after 180 we have 190, number 3. And then after 190 we have 200, number 4. 225, number 5. 245, number 6, and then number 7. So that's how I'm going to number them and how I'm going to plot them on my sheet. So starting with A, 160 in, up 40, down 70. So with an XY line, roughly going across the middle of your page, and put it in ever so lightly to start off with. Pick a start point. So from that point there, where I'm going to do all my measurements from, I'm going to measure in 160. So I know I'll be accurate then. So 160, my second one was 180. My third one was 190. So I like to do all the marks first, and then the fourth one was 200. So right into the middle of the page. The fifth one was 225, so 22.5 centimeters. The sixth one was 245. And the last one was 260. Okay, so with all those marks plotted, now I'm going to do the vertical and the vertical coordinates. So it's up 40 and down 70 for A. So it'll be up 40, down 70. So what I like to do is just do a line like this. Measure down 70, make my mark, up 40, make my mark. So that's A done. Next one is number 2, up 80, down 35. So I'll go down 35 and up 80. So do a line down. So 35 down and be 11.5 up. Now up 80. Let me just make sure. If you're not sure the maths, there we go. Number 3 then, which will be point number F, will be up 40, down 75. So 75 down. And up 40, 10, 20, 30, 40. So that's the third one. The fourth one is 0, so it's touching the ground, so there's a point right there, and it's down 115, so 11.5 down. So that's that one all the way down there. And the fifth one, up 105, down 10. So up 10.5. The very tip top, down 10. Continuing that sequence, I'm on to the sixth one now, and that is 0 and 95 down. So there's the 95, and then the very last one, we're not given the coordinates for G, so I'll just do a line up and down there because it has to be up and down along there. Now, with those points, I'm going to write in the letters. So the first one was A, so there's A and A. And then the next one, number 2, was B and B. I've got B up here, and I've got B down here. Okay, then number 3 was F. So I've got F, just going to see how I'm going to write these in. So we'll go about here. So there's F, and then down here as well, I'll put F inside there. Okay, number 4 was C, 200, so C is down here. There's C there, and C here. Okay, number 5 was D. Okay, so D is up here, and D down here. And then number 6 was E. E is on the ground. I'll mark E out here, and then E out here as well. And the last one then is G. Okay, now that I've got those plotted, I'm going to connect those up. So I've got a plane ABC. So I'm putting these in nice and lightly first. I will go over them with my marker just in a second to make it stand out a little bit clearer on the screen. So there's ABC. I'll connect them in the plan view as well. A to B to C. Okay, then I've got ABD. So ABD as well. So there's ABD. ABD is here in the plan. Okay, and then they tell us EF and G. Now I've got the line EF in elevation. I've got the line EF in plan. And they give us a bit of information. They tell us that the edge FG is parallel to the edge BD. So parallel to BD in elevation. Do the exact same in plan as well. Parallel to BD. Do a line across like that. That there will locate G for me. G connects down to E. Okay, so now that I found G, I'm going to write that in. Okay, and I have to do the exact same in plan, parallel to BD in plan. I do it from F. Just have to bring it down a little bit further, sorry. So from F, parallel, from F, and there we go. Connect it down. There you go. I have now got G. And all I'm going to do now is I'm going to heavy in those where appropriate. So edge here was in a slightly hidden detail because it's hidden slightly underneath it. So I got this edge, the edge from B to D. Just switch out my marker there, apologies. Got the edge from A to B. Heavy all these as we go along. Got the point F. So here's our planar surfaces. And then F to G. Okay, so there's the plan view heavied in. Now I'm going to heavy in the elevation. So A to C, A to B, just using the sheet for reference. And then this edge, once again, a bit of hidden detail here, because the face ABD is behind the face ABC. So I'm seeing the edge from A to D, slightly in hidden detail. Once again then, FEG. Okay, so there's the elevation on the plan drawn. Part number 1 of the question, just for plotting points, I'm going to write in there X, Y line. Okay, so there's the part A of the question done. Draw the elevation and plan of the intersecting planes ABC, ABD and EFG. Part 2. Determine the dihedral angle between the planes ABC and ABD. Okay, dihedral angle, what we have to do is we have to find the common line between them, between the planes ABC and ABD. So they're on about these two here. We're not talking about FGE or EFG, okay? So we're only talking about these two. So first of all, we have to find the common line between them, the line of intersection. What's the common line? It is the line AB. So we've identified the line of intersection. Step number 2 is I have to see the line of intersection as a true length. Now, is it a true length in elevation? No, because the line AB in plan is not parallel with the XY line. Is it a true length in plan? No, because once again, AB in elevation is not parallel with the XY line. So I have to see it as a true length. Now, the only way I can see it as a true length is when I look perpendicular to it, okay? We could either project out this way, okay, but because I've kind of got limited space down here, I'm going to project out this way first. So I'm going to set up an X1, Y1, looking perpendicular to it, so it's going to be an X1, Y1 looking perpendicular, and the X1, Y1 will be parallel to the edge AB. I'm going to simply project it out. I'm just going to see where will work best. Let's say about here, I think. Projection plan, I'm going to take my heights from the elevation. So I'm going to set up, as I said, an X1, Y1. It's going slightly in there, that's fine. I'm just going to label that X1, Y1. Now all the points on the object, C will project out A and B. A will be there somewhere, B up there, and finally D up there. Okay, if we project on the plan, we take our heights from the elevation. So, using a compass, easy one to find straight away is C. C is on the ground, it has no height, so if I follow it down, mark it up on the X1, Y1, that would be now C1 right there. Now if I want to find A, I'm going to take the distance from the XY line up to A, mark it off, and mark it out. Project out from A, from the X1, Y1, mark it up. So that there now is A1. Okay, and the same principle then for B and D. So the height up to B. There's the height up to B, mark it out from B. Okay, and finally the height up to D. So I'm taking that height there. Happy with that. I'll mark it from here. Just need to extend my line up a little bit further. Okay, and I will just draw in the X1, Y1 a little bit inside there. Okay, probably didn't need to draw it inside there for a little bit of neatness, but I have it done. Doesn't really matter. So once again, I'm just going to label my points. This here is B1, and then we've got D1. Okay, so let's draw on the planes. I've got a plane ABD. Most importantly though, I now have the line AB. That line there is a true length. So ABC. And then I've got the plane ABD. So B connects to D. D back to A. Okay, now how would that appear? As I'm looking in at it in this direction, I'm just seeing here, which faces will I see? I should think, will I see both of them? No, there will be a little bit of hidden detail. So is it the edge from A to D? As I'm looking in at it in this direction, just have to work this out here, guys, apologies. So the edge AB anyway, first of all, will be fully heavy. That there is my true length of the line of intersection. And as I look at it in this direction, I do think I'm going to see the edge. And B is above it. Yes, the edge from A to D again. There we go. So A to B. That's all going in. ABC is going in heavy. B to D, heavy. B to A, heavy as far as there. And okay, but most importantly, the line AB, I have that now as a true length. So I'm going to mark that just there as a true length. Now what's helpful about that is, because the line AB is on both planes, ABC and ABD, when I look along a true length, I will then see that true length as a point view, but more importantly, I will see those two surfaces then as edge views, okay? Therefore, giving us the dihedral angle between them. So all I'm going to do now is I'm going to set up an X2, Y2, And that x2, y2 is going to be looking along the line, but it's going to be projected perpendicular to it. So I'm going to rotate here. And this is going to be my x2, y2. x2, y2. Now every point then is going to project up perpendicular to that, or parallel to the edge AB. So AB will project up. It's going to be somewhere up there, as will D, and as will C. Okay, so now that I projected those up, rule of thumb here now is that you take your distances from the previous XY line back. So just based on the height I have for C here, I'm just going to check because this is quite a long one, just to make sure that I don't have to use a datum line. So that distance there, if I mark it from here, it's just fitting in my page. I know it's kind of gone off the screen there, so I'll just pull it up here. It's just fitting in my page, so I've just fitted it. So I'm taking my distances from the previous XY line back, which in this case is the X1, Y1, back to C. So if I want to find C, project it out from the x2, y2, mark it up. So that there now, it's very hard to see there, but that there is C2. Okay, I'm going to continue on with this now. I'm going to do the distance from the x1, y1 back to D, which is that distance there. I'm going to mark it from D. Okay, and then finally the distance from the x1, y1 back to B, which is the same as the distance back to A. Therefore, I'm seeing AB, the true length line, as a point view. Okay, and there we have it. That there is, I'm going to call it A2, comma B2, and this is D2. All I'm going to do now is connect those up. ABC, ABD. And it might look a little bit funny, but that is the dihedral angle between them. I'm going to just simply connect that there. Connect that. Okay. And more importantly, the angle inside there, if you came along and measured that, that is our dihedral angle. Now it may look like there's a larger gap, but that is the size of it. Okay, so there we have it, folks. That there is the second part of the question done. I'm just going to adjust the camera there a little bit so we can see that fully. So we've got the dihedral angle there. That's the second part of the question done. Determine the dihedral angle between the planes ABC and ABD. Part C, draw the elevation and plan of a horizontal line on the surface EFG and project an auxiliary elevation which will show an edge view of the plane EFG. Indicate the angle of inclination of the plane EFG to the horizontal plane. Okay, they actually tell us what to do. Draw the elevation and plan of a horizontal line on the surface EFG. So draw the elevation and plan of a horizontal line on the surface EFG. So EFG, I want to draw the elevation plan of a horizontal line on that surface. So I'm going to use a point that's in the middle. E is at the bottom, G is the highest, F is in the middle. So from F, I'm going to do a horizontal line across like that. Now what's helpful about that line is, that line then, it hits the edge from E to G. So now I have to draw the plan view of that line. So I've drawn the elevation. So all I'm going to do is I'm going to bring that guy down now to the plan. That's where it hits in the plan. I connect it back to F. Now what's helpful about that line is that the line and plan, that one there, is a true length. The reason being is because after I drew it in elevation, after I drew that line in elevation right there, I'm going to put this in red this time actually. So by drawing in the horizontal line in elevation, in the plan view, when it's horizontal in elevation in the plan, it will be a true length. Okay, and because that's a true length, what they've asked me now is they want to see the plane EFG as an edge view. I want to see the surface as a line. And when I look along a true length on any surface, like we did here previously, we will then see that surface as a line, or what's known as an edge view. So all I'm going to do here now is I'm going to project another auxiliary. Okay, and it's going to be set up perpendicular to the true length. So, looking out along that, that'll project out. G will project out. and E will project out. I'm going to set up perpendicular to it. I'm going to set up my, in this case now, I suppose we're on to an x3, y3. Since we're starting a new one, sometimes I would call this an x1, y1 again. And all I'm doing is I'm taking the heights, I'm projecting from the plan, I'm taking my heights from the elevation. So, helpful here straight away, E is on the ground, so if I follow it out, that's where E is. In this case, it's going to be E3. Okay, now I'm going to take the height for F. It's that height there. Make sure I've done this accurately. There's F. I'm going to mark it out from F here, because F is projected out. And lastly, I'm going to do the exact same with G. And there's G. Mark out for G. Now, if I'm accurate, all of these should meet in a straight line. What I usually do here is I connect the highest one with the lowest one, and it should go through that one if I'm accurate. Now, these questions, it can be very hard to be 100% accurate all the time. Just going to check these, I'm going to check it out. Yeah, that worked out absolutely perfect. Doesn't always work out that way, but it did go through all my 3 points. So, what we're going to do now is just going to label these. That there is F3 and this is G3. Okay, so what we have now is we have the surface EFG as an edge view, but more importantly, if we just refer back to the question, it says here, indicate the angle of inclination of the plane EFG to the horizontal plane. Now remember, this is an auxiliary elevation over here, so technically the X3, Y3 line is representing the ground, which is the horizontal plane. So all we have to do then is, we're going to measure the angle that that surface makes. I'm going to pop my protractor on it here. Just make sure I have it set correctly there, right on the point. There we go. And I'm going to read the angle, and for me it's saying 50, 1, 2, 3, 4, I'm going to say 55 degrees. Okay, so there's our 55 degrees, writing that in. 55 degrees. That is the angle, inclination, I'll just write it in here, inclination of EFG to HP. Now you don't have to write that in, but just letting the examiner know when we can. Okay, so there we have the part C of the question done there, folks. And the last part of the question, part D, it says locate the position of a point P on the plane EFG, which is a distance of 40 millimeters from the horizontal plane and 68 millimeters from the vertical plane. Okay, and then it says determine and indicate the true length of a line FP. So locate the position of a point P on EFG. So they're basically asking us, we have to find a point in here on this surface EFG in both the elevation and the plan. So how do I do that? And it gives me a bit of information. It's a distance of 40 millimeters from the horizontal plane and 68 millimeters from the vertical plane. Okay, so if I focus on the elevation, the ground line, the XY line, is my horizontal plane. That's the ground. So I simply have to measure up 40 millimeters. And if we actually look at F, well, F is already up 40 millimeters. So with that actual height already measured. So somewhere along that line has to be the point P. Okay, and because I have that line in elevation, I already previously found it in my part C in plan. So technically that is the plan view of that line. So my P actually has to be somewhere along that line there. Okay, then it asks us, it tells us that the point P then is 68 millimeters from the vertical plane. Now in my plan view, the XY line is my vertical plane. That's like the wall. So all I have to do in my plan is I'm going to measure down. I'm just going to use a line here that I've already measured on. So using this line, I'm going to measure down from the XY line 68 millimeters. So that's 60, 61, or 66, 67, 68. So there's the 68 millimeter mark. Now that I've done that, I'm just going to do a horizontal line. And technically, somewhere along that line, okay, is going to be where point P is. And if you remember previously, somewhere at the height line of 40, I found that down here, okay. So by bringing that down here, somewhere along that line had to be P. So where the two intersect, right in here, has to be, that's point P. So now that I've found point P, okay, can I find it in elevation? Yes, I can. I won't have to technically put it in because it just wants the true length. If I wanted to find it in elevation, that's where it would be. Okay, so there's P in elevation, there's P in plan. And all they ask us then is determine and indicate the true length of FP. Well, the true length, because this line from F to here is already a true length, well, I can simply measure the distance from F to P and indicate that. And that there is telling me that the distance from F to P is, as I'm reading mine there, I'm saying 45 millimeters. And there we have it. That there is the true length from F to P, and I've indicated that. So there you have it, folks. That there was the 2022 question based on the topic of intersecting planes. Hope you found that out.